Yes, do you want to turn it so I can see it? Okay, right, I think it's about 2 o'clock, so I'll get going. Let me start by explaining why there are various cameras around. I thought I'd start recording lectures and putting them on YouTube. Okay, this way, you know, if I'm not clear or you want to see exactly what I said, you can watch it again. And I don't know, some African school kid can watch me as well if they really want. There are various different cameras, but I don't know which of these is going to work. So we'll see which one works. Next slides, we should be fine. I was expecting about 45 of you. There seems to be a few more than that. Who didn't put this down as one of our options, and you're just saying if I'm any good before you make a decision? No, a few of you. That's fine. Okay, shall we get going? So this is industrial organisation. You haven't come to advanced microeconomic theory. Many of you I recognise, I taught either last year or the year before. Some of you don't know me, so you don't know what you're letting yourself in for. Before we get going, the course website is io.tholden.org. Everything will be on that website. So already the last 2 years of lecture slides are on there. This year's slides will be almost identical to last year's slides, so you can read ahead and read the whole year's slides before you start if you really want to. And it's a blog, so you can actually comment on the blog. You could do this last year with microeconomics as well, but no one did. I want to encourage you. Let's be 20th century. So comment on the blog if you don't understand something. I'll write a reply there, and that way everyone can see the reply, and maybe that helps everyone rather than just okay. So yeah, you know my email, t.holden, sorry. Okay, my office hours this semester are Thursdays 2 till 4. But what I thought I'd do was to run a class in the first hour. So I'm not paid to run a class. Okay, some modules have a TA running a class for them. I'm not paid to run a class, but if people want a class, then I'm prepared to run one in the first hour of my lectures. Okay, so if you want to go in for problem sets, I'll be in room 40AD00, which is the seminar room in the economics department for a class Thursdays 2 till 3. Okay, if no one turns up, I'll just be in my office. Okay, and I'm only going to go over questions if you guys have at least had a go at those questions first. Okay, or it's something you didn't understand in the lectures. For other problems, come to my office in the second hour. You know, if it's something that you don't want to discuss in front of everyone else for some reason. And it's always a good idea to email first so I know that you're going to be coming. And if you want to come at a different time, then email me first, it might be possible. It's Thursday 2 till 4, fine for everyone, it doesn't clash with anything.
You know the classes, they clash with the game theory?
So clashes with what?
Game theory?
So when's game theory?
1 to 3.
1 to 3. Okay. How many of you are doing game theory? quite a few of you. Okay, well, I'll see what I can do. So the seminar room is almost entirely booked up. So I can't do the class 3 till 4:30 because that slot is booked up by someone else. Maybe I can do it in the morning, but we'll see. I'll record the classes as well, so you can always watch the classes if you want to find out what this is. Okay, we'll see. Has everyone got a handout? For some seats in front. Okay, so like I said, report to the website io.eon.org. If you go to Surrey Learn, it'll just redirect you to my site. Last year's price, please comment if you have questions or things that you want clarifying. I'll be posting links to the YouTube videos of these lectures on the course site as well. As long as one of the cameras works. Okay, so the main reading for this year is this guy's book, Oz-Shy, Industrial Organisation. The library has 8 copies or something. The first year I taught this course, there were only 16 people taking it, so maybe 8 between 16 was okay. Now I guess some of you guys are going to have to buy the book. It's kind of, it should be about the ideal level of difficulty. Not too easy, not too hard. You know, so it's some graphs, but it's reasonably mathematical where it needs to be. If that's too easy for you, if you want to be challenged a bit, you want to get some bonus points on the exam, Jean Tirol's textbook is excellent. He's one of the most famous microeconomists alive today. It's also quite difficult. Okay, so if you're ambitious, then maybe have a look at that one. Otherwise, don't worry. And if you can't get a copy of Oz-Shy for some reason, then these guys' textbooks, Jeffrey Church and Roger Ware, is available for free online. Okay, perfectly legally. Okay, so there's a link to download it there. So that's free and legal online. Other ones maybe you can get online as well, but that's for you. And you know, don't be afraid to Google something. If you don't understand the term, Google it. There's probably a Wikipedia page on that term, and it's probably okay these days. So the exam structure is going to be. I'm going to need a bigger room. I presume after this lecture, most of you will decide you don't want to do this course anyway. Anyone else? I was expecting about 45 people, and I printed 60 of these, so for a few more. Okay, so the exams will be a mid-term test. Last year it was a multi-choice test, and you can actually find the mock multi-choice test from last year on the web already. The external examiner doesn't like multi-choice tests, so this year it's going to be a short answer test, and I'll give you some points for workings as well as the final answer. But it'll be very short answers, so not my usual questions. And then the test will be in week 6, the first one, and I'll provide it. It will be an end-of-term test, which is 20%, with longer maths questions, up to 2 hours, and again, I'll provide a mock. And then the final exam will be a kind of mix of these 2 types of questions, right? So some of it will be very short answer questions, some of it will be longer questions, but will require some maths and a bit of discussion as well. And I'll give you a mock. So it's very important that you do some exercises. You know, really, the best way of learning is to put it into practice, do the exercises, check you understand things, come to classes if you don't understand what's going on. So Oshlo's book has lots of exercises, and at the end of each lecture I'll give you a pointer to a few that are particularly relevant to what we've done, but you know, feel free to do some other ones as well. And conveniently, the answers to all the exercises are online. Okay, you can click on that. If you go to my website, all these links are clickable. But don't look at the answers before you've had a good go at the exercise. And I'm happy to go over questions in the class as well if the answers aren't very clear. Okay, and so as well as the questions in the books, there are some extra questions on his website. Again, this link will take you to it. If you go to my website, look at these slides, it'll be clickable. The solutions are there as well. Okay, and there'll be a few other questions. So are there any questions on generally how the course is going to work before we get down to business? Okay, so what are we doing? So first question, we've got a laser pointer as well. First question, what is I/O? What have you signed up to do? Well, industrial organisation is not the study of heavy industries rather than agriculture. Okay, so if you thought you were going to be studying industrial processes or something, you've come to the wrong place. What industrial organisation is, it's the study of the interactions between firms. You know, so what a firm is, how a firm behaves, how markets are structured, how firms compete, how we go about regulating those markets if competition isn't working for some reason. There's a chair. What's happened? Do you need a chair? This. Okay, if you want a job in economics, maybe you want to become an economic consultant. Well, industrial organisation is a field to do because a lot of economic consultants are doing industrial organisation. Some big firm comes along and they say, look, we're introducing this new product. How should we go about marketing it? How should we go about pricing it? How much effort should we put into advertising? These are the kind of questions that industrial organisation can answer. And also, the government often hires economic consultants to assess these issues around regulation. So, you know, the government will hire economic consultants to look into whether the airline industry is overly concentrated or something similar. Okay, so it's quite a useful field. What we're going to be doing is mostly the theoretical groundwork. Okay, there'll be some applied stuff, but really I want to give you the theoretical tools that you need in order to go then and tackle some practical problems. Okay, so you know, we cover the tools here, and you should be able to work out how you can apply those tools to real-world problems. You know, we'll look at some real-world problems as we go, but it's going to be mostly about these theoretical tools. So what kind of topics are covered within industrial organisation? Well, decisions of the firm, so entry, when should I enter an industry? You know, maybe there aren't many companies making breakfast cereals at the moment. Should I start up as a new company making breakfast cereals? Am I going to be able to make profits if I do that? Or maybe I'm currently making breakfast cereals and I'm getting a lot of competition from Kellogg's. You know, at what point do I cut my losses and just leave the industry? When should I merge with my rival? Okay, is it ever a good idea to merge? Research and development. Okay, so we think of research and development as kind of increasing a firm's productivity or decreasing their costs. So it's going to be quite a complicated economic decision how much research and development they ought to do. And it's going to depend on the competition structure I'm working with them. Advertising is similar. You know, if I advertise my product, it costs me something, but maybe I get more demand, so there's a trade-off there. Maybe I can steal demand off my competitors, maybe I can drive my competitors out of the market, even. And capital investment and similar problems to R&D. Pricing is going to be a big thing that we look at. You've seen in microeconomics in the first term, you should have seen Bertrand and Cornell competition. Don't watch out at once. Yeah, some distant nods. Okay, so we'll do some things to Bertrand and Cornell. We'll extend Bertrand and Cornell in various ways. We'll look at why some of the results you saw previously might not hold once you get to the real world. And we'll look at some other types of competition as well. This is, pricing is quite tightly related to market structure. So how are these firms interacting? Why do we get some big firms? And why are some industries highly concentrated? So that means there aren't many firms in that industry, whereas some are really competitive. Okay, so airlines are quite highly concentrated. There aren't many. There's not much competition flying out of Heathrow. You're either going to fly British Airways or Lufthansa, probably. If you want to, I can't think of a good example now. If you want to buy some paper, then there are lots of companies that will sell you pieces of paper. The price is quite close to multiple price. So what is it about airlines and producing paper that means one is concentrated? Okay, so these are the kind of questions we'll be looking at. And also on competition policy, what is collusion? How do firms go about colluding? Can we analyse that in a theoretical way? And how then does the regulator go and stop them colluding? Make everyone better. Okay, so industrial organisation is a big subject, but as I said, the aim of what I'm teaching you will be to give you the theoretical tools you need to go off and apply it to real-world problems. Okay, so I'll give you the tools, and then it's up to you to take it to the real world to a certain extent. I personally think the theory is quite fun on its own. It's basically applied game theory. So if you're doing Paul Levine's game theory course, then that's only going to help you do that. Okay, there are some overlaps there, so I guess it makes sense to do both. It is Paul still teaching game theory, right? So the advanced economic theory thing. Okay. And it's called advanced economic theory, or it's called game theory?
Game market information.
Yeah, that's cool. Okay, so it changed. It used to be called. And there's also the advanced micro theory, which will also have some overlaps with this. I've been told that's very difficult. The advanced micro theory. So it's a buyer beware. If you want to look good when you leave this place, you should do as difficult courses as possible. Okay, it's in your best interest to do difficult courses. Because employers know that some courses are harder than others, and certainly if you want to go on to do a master's or a doctorate, then doing these hard courses will really help you. So I'm sure it's a good course. I'm not saying don't do it. Okay, so what we're going to do today is basically revision. Okay, I'm going to really go back to the basics of demand and monopoly pricing, perfect competition, things you've seen 1,000 times before, but I guess some of you have been away on placement for a year, so maybe it'll take a little while for your brain cells to get firing again. And maybe we're going to do things in a bit more depth than what you've seen before. Okay, so we're going to take a slightly more mathematical approach to what you've seen before, and these mathematical tools are going to help us in later weeks. Okay, so let's start at the very basics of Economics 101. You've got supply and demand. So let's think about what a demand curve is. Okay, if you're a firm, you really care about what the demand curve is. So there are two ways we can think about demand curves. The first is the related homogeneous consumers. Homogeneous means everyone's the same. Okay, homogeneous consumers they all want multiple units of your product, okay, and they all have the same preferences. And the other way is for lots of heterogeneous consumers. They each want, so heterogeneous means they differ in some respect, and they each only want one unit of your good. Okay, if you've got lots of people and they all want several units of your good, maybe it's paper, okay? So maybe I'm prepared to pay £10 for 1,000 sheets of paper, or £15 for 2,000 sheets of paper. Okay, then I personally have a downward sloping. I have a normal demand curve myself. Okay, and if everyone has the same preference, then the aggregate demand curve is just going to be the sum of all of these individual demand curves, and the aggregate demand curve is going to look pretty similar to each person's individual demand curve. Okay, so when everyone's the same, everyone has their own demand curve, if you like. It's kind of easy to see what the aggregate demand curve is going to be like. Okay, but how's it going to work with these heterogeneous consumers, where everyone only wants one unit of the good? So how might you get a nice, well-behaved aggregate demand curve, even if each individual person only wants one unit of the good? So think about mobile phones, maybe. You all only want one mobile phone, I presume. But some of you probably have 10-year-old Nokias. Some of you probably have the new iPhone 5, whatever it is. So where might an aggregate demand curve come from in this case? Go on, you want to say something? No? So, well look, let me show you graphically how the homogeneous case works. And maybe while we're doing that, you can think about how the heterogeneous case might work. So the camera operators might have to go around. That one seems to have turned off. Hopefully we'll have something to put on YouTube, but I don't know. So maybe for two people, okay? Okay, I'm drawing a demand curve. What am I putting on these axes? Let's just check someone's away. One, two. Okay, so let's say this is person 1. This is person 2. And this is the aggregate. So we're two people in our economy. Okay? The first person, this is for demand for sheets of paper. The more expensive paper is, the less you want to buy of it. So there you've got a nice, well-behaved demand curve. Person 1. Person 2 also has a nice, well-behaved demand curve. What's the aggregate demand curve going to look like? Yeah, it's just going to look the same. It's the sum of these two. Okay, so if this is 1, if this is 1,000. Price, isn't it? Maybe that's £1. And this is 1,000 sheets, maybe. So it's going to look the same, but it's going to go to 2,000 sheets. So when everyone has nice, well-behaved preferences, it's clear where we get an aggregate demand curve from. What about if we have this case here, where each person only wants one unit of the good? What will their demand curve look like? Yeah, you kind of do that again.
Just a straight line.
Yeah, so there's some point that there's some amount they're prepared to pay for the good. If the good is less than that price, they'll buy it. If the good is more than that price, they won't buy it. Okay? I'll use a different colour. Let's see the difference. Okay, so maybe your demand for mobile phones looks a bit like that. Okay, here's one unit. Any price less than some amount, I'm prepared to buy the good. Otherwise, I won't buy the good. Okay, I just want to buy 2 mobile phones. and I'll buy no mobile phone at all if mobile phones are too expensive. Okay, so here's one person, they've got preferences like this. So maybe person B has preferences that look like that. So, no, I've drawn this wrong. They still want 1 unit. Okay, but maybe they're prepared to pay more for it. So what would the aggregate demand curve look like in this case? It's made slightly difficult because we always draw demand curves kind of 90 degrees of a sensible way. You know, quantity is on this axis. Okay, so when you add two demand curves together, you're kind of adding that way. So what you get in aggregate, well, let's just make this a bit clearer. So here's the first guy. He's prepared to buy even if it's quite a high price. So if it's a price in this interval between the first guy's demand and the second guy's demand, here was the second guy, then only the second guy is going to be prepared to buy. The price is in this interval, only the second guy buys the good. Okay, so the quantity demanded is going to be 1. But if the price is below the maximum this first guy is prepared to pay, then both guys are going to buy the good. Okay, so the aggregate demand curve will look like that. Is that clear? So you kind of stacking things upwards. So this is with 2 people, and you know, this guy had a low reservation price, this guy had a high reservation price. If you have 10,000 people in the economy, or 10,000 people buying your good, then sooner or later you get a nice looking aggregate demand curve. Okay, so when we talk about demand curves, it's always going to be helpful to think about 2 different ways of interpreting demand curves. The first is when everyone is the same, that each person demands multiple units of the good. Second is when everyone has a different reservation value for buying the good. Okay, this is just notation. We're going to denote demand curves by Q of P. So demand is a function of price, and the inverse demand curve will be P of Q. Price is a function of quantity. Okay. So this is almost a silly question. So if I gave you Q of P, if I gave you the demand curve, how would you derive the inverse demand curve? Yeah, rearrange for P, exactly. And in this kind of general way of So what rearranging for P means is inverting the demand curve. Okay, so you've seen inverse functions before, haven't you? So I'm giving you Q of P. Giving you Q of P. Okay. So you know that this function Q of P is giving you the amount demanded. So we're not using the same letter for multiple things. Let's call the amount demanded y. Okay. So Q of P equals y. Well, what happens if we apply the inverse of this Q function? Q is the demand function. Let's just apply its inverse to both sides. So Q. Do I have any pens for it? There we go. So Q inverse of Q of P is equal to Q inverse of y. So, you know, if Q was the square root, okay, Q inverse would be square, someone said, yeah, square is the inverse of square root and vice versa. Okay, every function, every nice increasing function that's continuous will have a square root. Okay. So without knowing anything about this Q function, do we know what Q inverse Q of P is? Any guesses? So you take a you take the price, you apply this function to it, and then you apply the inverse of the function to it. What do you get back to? P, exactly. Okay, so Q inverse of QP is just P. So this equation says that the price is equal to Q inverse of Y. Okay, so we were looking for the inverse demand curve. Price is a function of quantity. This Y is our quantity now. Okay, so the inverse demand curve, P of Q, is just the inverse of the demand curve. Okay, so this is just a mathematical relationship that lets you map between demand curves and inverse demand curves, even if you know nothing about the demand curve at all. Okay, so microeconomists tend not to like specifying functional forms. Okay, they like to be as general as possible. So this is kind of how you can go about being general. You don't have to specify a functional form, but we can still get the inverse demand curve from the demand curve. And it's kind of unsurprising. This is the inverse demand curve, and it really is just the inverse function of the demand function. It's almost obvious. Okay, so we're going to be two families of demand curves that we'll use a lot. One is linear demand, which I guess you've seen quite a bit. Okay, so the quantity demanded at some price is some quantity that's demanded at any price plus some function of the price. Okay, this is going to be Q1 will normally be negative. Okay, or we can look at a linear inverse demand curve. Again, similar form. Okay, so linear demand you've seen lots of times, but we'll also use isoelastic demand quite a bit. And this says that the quantity demanded at some price is some constant times price to the power of some negative number. Okay, so maybe if alpha was 1, this would be some constant divided by the price. Okay, you know what a graph of 1 over x looks like? Okay. So if alpha is 1, it's going to look like that. So you can have isoelastic demand curves, or equally you can have isoelastic inverse demand curves, where the price as a function of quantity is some function of this form. Okay, I know this is a bit tedious, but we're going to use these two classes of demand curves quite a bit. Okay, so the question I ask on the board is, how do we map from the parameters of this demand curve to the parameters of the inverse demand curve? So if I told you this was the demand curve, how would you go about solving for the inverse demand curve? Okay, do you want to have a go at working out the values of P0 and P1 as a function of Q0 and Q1? Do you see what you have to do? So I'm giving you, this is the demand curve. I want you to work out the inverse demand curve. Okay, and see if you, once you've worked out the inverse demand curve, maybe you can then work out what P0 and P1 must be. No, so what you now want to do is kind of equate the terms. So equate the constant term and equate the linear term. Okay. So the first bit's easy, right? In converting the demand curve. Okay, so we were told that Q was equal, big Q was equal to Q0 plus Q1 times price. Okay? So big Q minus Q0 is equal to Q1 times price. So if we divide both sides by Q1, price is equal to big Q minus Q0 all over Q1. Okay? So let's just rewrite this a bit. The term in the, we've got a constant term, okay, which is minus Q0 over Q1. So we've got minus Q0 over Q1 plus 1 over Q1 times big Q. Okay, do you see those two lines are the same? So all we've done is we've taken the constant bit and put it in the front, and then we've got this bit left, which is Q over Q1, and we're just writing that as 1 over Q1 times big Q. Okay, we were trying to get an inverse demand curve that looked like this one. P of Q is P0 plus P1 times Q. Okay, so here we have a constant bit and then something multiplying quantity. So in order to map between these little q parameters and these little p parameters, all we need to do is to set little p equal to minus q0 over q1, is p0, and little p1 equal to 1 over q1. Does that make sense? Remember what we said, that Q1 was normally going to be negative because demand curve slowed down. Okay, so if Q1 is negative, then P1 is 1 over Q1, and P1 is going to be negative as well. So if the demand curve is sloping down, the inverse demand curve is sloping down as well, which is what you know. Okay, so it's a simple exercise, but sometimes it'll be more useful to work with demand curves. Sometimes it'll be more useful to work with inverse demand curves. Sorry for you guys over there. Maybe I should use the big one. Can you see exactly? Okay, so this linear one was quite straightforward, hopefully. Do you want to have a go at this isoelastic case? Okay, so here's demand Q is given by C times P to minus alpha. So can you invert that demand curve and then work out what K and beta must be? People about done? Yeah. Could you possibly point the camera around this forward? Yeah. Okay, so we were told the quantity demanded was this function of a price, c times p to the minus alpha. Okay, so first thing we're going to do is divide by c. Okay, so q over c is going to be d to the minus alpha. Nothing difficult. Okay, next thing we want to do is to get rid of this power of minus alpha. So to get rid of a power, we have to raise to the power of 1 over that number. You know, the inverse of x, if you've got x squared, you know, if you've got x squared is y, then to get x as a function of y, you take the square root of both sides. So x is square root of y. Okay, another way of writing that is x is y to the power of a half. You take the number, you take the inverse of that. Okay, so if we want to get a price out of this equation, we have to raise both sides to the power of minus 1 over alpha. Okay, so q over c to the power of minus 1 over alpha is going to be equal.
Can I write as c over q and like just c over q then 1 over
Yeah.
like that same thing.
Yeah. Okay, so another way you could go about doing this is p to the minus alpha is 1 over p to the alpha. Okay, so maybe you might want to first invert both sides. Okay, so c over q is equal to p to the alpha. Okay, so c over q to the power of 1 over alpha is equal to p. Okay, these two things are the same. Okay, because you've got a minus sign there, that's the same as that. These are two different ways of writing it. Okay, so we want. What that? Is that what you want? So we wanted to get it to this form, so price was something times q to the power of minus beta. Okay, so let's split this expression up into two parts. So we've got a constant over front and something times q. Okay, so this is the same as q to the power of minus 1 over alpha times 1 over c to the power of minus 1 over alpha. So p is equal to that. And we've got a 1 over here, we've got a minus sign there, we can just write that as c to the power of alpha, c to the power of 1 over alpha, sorry, times q to the minus 1 over. Okay, so our constants k and beta, well, k must be this thing, c to 1 over alpha, k is c to 1 over alpha, and beta must be 1 over alpha. People happy with that? Yeah? Okay, it's pretty tedious, I know, but it's important that you're comfortable doing these tricks with powers. You know, we'll do lots of tricks with powers at various points. So it's good that everyone understands this stuff early on, and if you want me to go over things, do say. It's good to get everything straight from the start. Some of you are bored with it. Okay, so could you turn the camera back? Thank you. So we had these two classes of demand curve, linear and isoelastic. And what we've done is just shown how you can map between the parameters of a demand curve and the parameters of the inverse demand curve. Okay, so sometimes we'll be working with demand curves, sometimes we'll be working with inverse demand curves, but you're always going to be able to swap between the two different types of demand curve. Okay, the next important thing about demand curves we have to talk about is the elasticity of demand. Again, you probably saw this in the first year, the definition of elasticity of demand. Okay, so the elasticity of demand is the change in log quantity as you change the log price. Okay, or it's the percentage change in quantity as you make a percentage change to the price. Or equivalently, it's this thing. Okay, it's the derivative of quantity with respect to price times price divided by quantity. And you've seen that formula before, haven't you? Yes. Okay. So, how do we find the elasticity of demand? And we have only the inverse demand curve. Okay. So now we're going to introduce another trick that enables you to work with general demand curves without knowing exactly what they are. Okay. So maybe I give you some inverse demand curve. P is a function of Q. Okay, and I say to you, well, what's the elasticity of demand? And you look at this formula, and this formula is in terms of quantity and price, the derivative of quantity with respect to price, whereas you only know price with respect to quantity. So maybe it's not obvious how you use this formula when you only know the inverse demand curve. Okay. You know, this is probably obvious to you. So what we need, okay, is the derivative of quantity with respect to price. Okay, and just from the way we write this notation for derivatives, you can maybe guess that that is equal to derivative of price with respect to quantity, all to the power of minus 1. Okay, so it's 1 over that thing. And okay, from the way you write the notation, that looks obvious, right? If you've got x over y, that's the same as y over x all to the power of minus 1. In fact, this is quite a difficult theorem to prove because this thing is just notation. But it turns out that this is true. Okay? So if you've got a function and you want to know the derivative of its inverse, you take the derivative of the original function and then you invert it. Okay, so here it is written slightly more formally. Okay, so we want to know the derivative of the inverse of some function f. Okay, so we want the derivative of f inverse with respect to x, and this inverse function theorem from maths says that the derivative of f inverse with respect to x is the derivative of f with respect to x, all raised to the power of minus 1. Okay, this is maybe difficult to remember. This is easy to remember, right? Okay. So if we only know the inverse demand curve, what's the elasticity of demand? Well, okay, so we're told that eta, its elasticity is dq over dp times p over q. Okay, so using what we've got here, that's p over q all divided by dp over dq. Okay, so we know the people say. I'll write it again at the top so you can see. So the inverse demand is going to be price divided by quantity. I can write it in this form even so it's clear. Okay, so times dp dq all raised to the power of minus 1. Okay, and that's just the same as price divided by quantity divided by dp divided by dq. Okay, there's a brackets. So if you have an inverse demand curve, you can still work out the elasticity of demand. Okay, you just use a slightly different formula. Rather than multiplying by the derivative, you divide by it. So once you've seen these things, they kind of seem too obvious to talk about. They're useful tricks. Okay, you'll see as we go on. So we want to talk about demand being elastic or inelastic. There's one slight complication with elasticities of demand. Are elasticities normally positive or are they negative? Yeah, okay, so the elasticity of demand can only be negative unless you've got really strange preferences, okay? So when you talk about something being, the elasticity being large, what you really mean is it's very small. You mean it's a long way below -1, okay? So it's convenient sometimes, rather than working with the actual value of the elasticity of demand, you work with the absolute value of the elasticity of demand. Okay, these two vertical bars just means if it's negative, make it positive. If it's positive, leave it how it is. Okay, these two bars are the absolute value. You should have seen that before. Okay, so demand is elastic when this absolute value is bigger than 1. Okay, or equivalently when the actual value is below -1. It's inelastic when the absolute value is less than 1, or equivalently when the actual value is between -1 and 0. Okay, so do you want to have a go at these two little questions? So what's the elasticity of linear demand? And more interestingly, what's the elasticity of an isoelastic demand curve? Maybe you can guess what it is from the name. Any spare handouts? I think that's a no. Okay. So have you had a go at these questions? Maybe not. I'll do linear on this board and isoelastic on that board. Fair. You might want to point. Oh, camera guy. What's your name? Sorry.
Holden.
Ardy. Okay. Could you?
Yes, sorry.
It's fine. Sorry. Okay. So what's the elasticity of linear demand? Okay. Well, remember, here was our linear demand function. So Q was Q0 plus Q1 times P. Okay. So the derivative of Q with respect to P is just Q1. So the elasticity eta is, Q1 times P over Q. And we know Q is a function of price. Okay. So that's Q1 times P over Q0 plus Q1 times P. Meaningful sign. So for a linear demand curve, the elasticity is changing. As you change price or you change quantity, the elasticity is going to change. So this says Q1 times P over Q0 plus Q1 thing. I'll write this up. Yeah. Q1 so that was the so it's Q1 times the
Oh, wait, no, actually. You don't mind me helping you. It's just differentiate.
yeah. Okay, so here we've got elasticity as a function of a price. Okay, if we subbed in the other way round, we could have got elasticity as a function of quantity instead. Okay, but the important thing is that this elasticity is changing. Remember that Q1 is going to be negative, demand curve slope down. Okay, so as price increases, the top of this increases, and as price increases, the bottom of this decreases. Okay, so this bit goes up, this bit goes down, so the whole thing goes up. So as the price increases, the elasticity increases within the demand. Okay, so if the price is really high, then demand is more elastic. So small changes in price have a bigger impact when the price starts out high, which is linear demand. But that's not going to be the case for isoelastic demand. Okay, so here was our isoelastic demand. Q was equal to C times P minus alpha. Okay, so let's plug into the formula again. So the elasticity is going to be derivative of Q with respect to price. Okay, what's the rule for differentiating things like this? If you've got the derivative of x to the n, the derivative of x squared, let's start with that. Yeah, okay, so derivative of x to the n, then plus x to the n is equal to this. Okay? It's been a long summer holiday. Okay, so we're going to apply that here. So we've got a constant out the front, and then we're going to get this minus alpha, so we pull that down, and we get p to the minus alpha minus 1. Okay, so that's our derivative, and then we're timing by p over q. Okay, so times p over q. What do you sort of get, or not get? Nothing. You sure? Okay, so we've got p to minus alpha minus 1 times p. So what's p to minus alpha minus 1 times p? How can we write that? Yeah, p to minus alpha. So this minus 1 bit just cancels out. Okay, so this is minus alpha times c times p to minus alpha all over q. Okay, do we recognise c times p to minus alpha? What's that equal to? Q. Yeah, so we started out with saying Q is C times P to minus alpha. Okay, so this is minus alpha times Q divided by Q. And people on that side say. I'll write it on that side as well. Okay, so the elasticity is just going to be minus alpha. Let me write the same thing over this. Okay, so Q would. Okay, so what's this told us? But with isoelastic demand, what happens to the elasticity as price or quantity changes? Stays the same, exactly. So why this part of demand functions is useful is precisely because of this. The elasticity stays the same no matter what quantity and price is. Okay, and I think you're all getting tired. We'll take a 5-minute break. Okay, so we've seen, you saw demand curves in the first year. You probably also saw consumer surplus in the first year. So, just as I kind of confused you with demand curves just now I'm going to confuse you with doing consumer surplus a bit differently. So let's suppose the consumers have a utility function that looks like this. Okay, so utility is a function of the quantity they consume is some function v of quantity plus m, where m is the money they have left over for everything else they buy. Okay, so they spend some of their money on buying this Q, everything else just goes for a general pot and they get some utility from that money. So maybe they can use that money to buy other goods, and we're just not talking about those. So what do we call this type of utility function? Thank you. Yeah, so this is a quasi-linear utility function, and a lot of what we do will be specific to these quasi-linear utility functions, okay? They make our life easy in various ways. Okay, so let's suppose their income is Y, and this good Q costs P per unit. Okay, so they've got a budget constraint that says their total income is their total expenditure, so price times quantity, what they spend on buying the good, plus M, what they have left over. Okay, so these consumers, well, they want to maximize their utility, this thing, subject to their budget constraint, this thing. Okay, so we can just substitute their budget constraint into their utility function. That's probably easiest. Okay, so what we want to maximize, if this is what basic equation gives us y as a function of p, q, and m, we can just write this to give us q instead. Okay, so y minus m is going to be p times q. Okay, so q is just y minus m. Well, doing it that way, that's not possible. Sorry, ignore me. You could have done it that way, but the way I've done it on the slide is a lot more sensible. When I wrote these slides, I was more awake. Okay, so y is pq plus m. So what's m? Well, m is y minus pq. Okay, so we can substitute that value for m into the original problem. Okay, so you want to maximize what's written on the slide. Vq plus this thing, y minus pq, is just m. Okay. Go on.
What's v?
V is some function. Okay? You'll see what v is later. It's just some function. So I called it v for a reason. Can you guess why it's v? What might v stand for? Pardon? Right.
Price is good, the price depends on
Yeah, but v, so there's a word beginning with v. Value, yeah. So you can think of this function v as telling you the value they place on getting that many units of the good. Okay? Okay, so here's what we're maximizing, v of q plus y minus pq. Okay, so we take the derivative of this, set it equal to 0. That's a first order condition. Okay, so I'll write it here because some people can't see. So we're maximizing v of q plus y minus pq. Okay, to maximize that, we take the derivative, set it equal to 0. So naught is equal to the derivative of its function, which we just write as v dashed. Okay, so we call that v dash q. Plus the derivative of this, that's just a constant, so it's nothing. Here we get a minus p. Okay, so I'll use these dashes throughout. The dash on a function means the first derivative of that function. It's standard. Okay, so v dash q minus p is equal to 0. then P must be equal to V dash to Q. So here we've now got a function V dashed. What does that function V dash look like? It's giving you price. It's giving you price as a function of quantity. So what is it? Yeah. So it's an inverse demand curve. Okay. So we started out with this utility, and just from maximizing a demand curve or an inverse demand curve, just pop down to the problem. Okay, so with these guys with quasi-linear utility, it's very easy to get their demand curve from their preferences. So as the price increases, the quantity they're going to demand will decrease because this thing will be down slightly. So inverse demand curves show marginal value. So I said we were talking about consumer surplus. Here's a graph you've seen before. Here's a demand curve. Okay, maybe the quantity being supplied is here, and it's being supplied at a price there. And I've shaded this area here, because this area is consumer surplus. Okay, you've seen this graph before, hopefully. Okay, so consumer surplus is the area between the demand curve and this line of the price. Okay. So with these quasi-linear preferences, we're going to see why this is a sensible thing to look at. Okay, why is this what we call consumer surplus? What does this measure? What's the point of it? Okay, so this looks a bit scary, this slide, but it'll be fine. So look, consumer surplus, given a certain quantity Q star and a price P star, consumer surplus was this area between the demand curve and this constant function of P star. Gone the wrong way, sorry. If we want to describe areas mathematically, what are we going to use? Integration. Exactly. Okay, so what we're going to do is we're going to write the area we just described as an integral. Okay, so it was the area between the inverse demand curve, price as a function of quantity, and the constant price P star. Okay, so that's subtracting that. So that's giving us this distance. Okay, and we want to integrate from quantity of 0 up to this quantity Q star. Okay, so this area we just described is the area that is exactly this integral. It's the integral from 0 to Q star of the inverse demand curve minus the price at which they're buying the goods. Okay, over quantity. But we said previously that if consumers have quasi-linear utility, then their inverse demand curve is just given by their marginal value, this V dashed thing. Okay, so we know that P is a function of Q is just V dashed of Q. Okay. So now there are two parts in this integral. So let's ignore this bit for now, because that bit's difficult. How do we integrate the constant P star minus P star from 0 up to Q star? How do we integrate a constant? Yeah, so it's just going to be the integral of minus P star from 0 up to Q star is just P star times Q star. Okay, all we're doing, is working out the area of a box. Okay, is P star is Q star. What's the area of a box? Well, it's length times width. P star times Q star. Okay, so that gets us this term here, minus P star Q star. So we've dealt with the easy bit. The bit left is this difficult bit. So we've got the integral from naught up to q star of v dash q. And maybe you've seen this before, but okay, there's this theorem called the fundamental theorem of calculus, which no one's heard of. You've heard of it, some people have heard of it. Okay, so all the fundamental theorem of calculus says is that if you take a function and if you take a function, you differentiate it, and then you integrate it, you get back where you started. Or the other way around, if you take a function, you integrate it, and then you differentiate it, you get back where you started. Okay, so the fundamental theorem of calculus is just saying that differentiation and integration are opposites in some way, that doing one undoes the other. Okay, so what we've got here is an integral of a derivative. Okay, it's the integral from naught up to this q star thing of v dash, the derivative of v with respect to q. Okay, so by the fundamental theorem of calculus, this is just v of q. Okay, so the integral of the derivative just gets us back the original function. Okay, at least as long as the value of consuming nothing is nothing. So what's consumer surplus? You know, so okay, maybe it seems a bit confusing. All you have to remember is when you've got an integral where you're integrating over a derivative, okay, the answer is just going to be the original function. Okay, you get rid of the derivative. Shall I? People are still looking confused. Let me see if I can. Okay, I'll show you a concrete example. Okay, maybe look. Suppose that v of q was q squared. Okay, this is a nice easy function to differentiate. Okay, but v dash q is 2 times q. Okay, we want to know the integral of 2 times q dq from naught up to q star. Okay, well, there's going to be 2 out the front. What's the integral of 2q? Yeah. Okay, so I will show you without doing any integration. You should be able to pass this course without actually learning how to integrate. So let's just do a graph instead. Okay. So here's 2. Here's 1. Okay. This is q. This is 2q. Okay. Here's a graph of 2q. Okay. In fact, we want it from naught up to q star. Anyway, so let's call that q star, and then this is 2q star. So what's the area of this triangle? Okay. Well, the area of the triangle is half base times height. Okay. So it's q star times 2q star, all divided by 2. Okay, so we get 2's cancel out, so it's q star all squared. Okay? What did we start with? Q squared. Okay, so by differentiating then integrating, yeah, we've got back what we started. Okay, and this isn't specific to, it's not specific to q squared. Any function, if you differentiate it, then you integrate it again, and the function is 0 at 0, you get back the original function. You happy?
My question was actually how you got from P to P.
Okay, so we saw, so that was just using this first order condition, okay? So the first order condition says that the market price has to be the marginal value. This has to be v dash. Thank you. Okay, so what did we see? We started out with this integral, which was a mathematical way of describing this blue area. And with these quasi-linear preferences, what we ended up with was VQ minus P times Q. P times Q is what they're paying. Okay, so this is what they're losing. VQ is kind of what they're gaining. Okay, so consumer surplus is measuring this value they're gaining minus the amount they're paying. Okay, so with quasi-linear preferences, consumer surplus is just a monetary measure of the utility gain that the consumers are getting from buying the product. Okay, it only really works with quasi-linear preferences, but this is why we look at consumer surplus. Okay, it's a graphical representation of this property of their utility functions, but the value they're gaining from consuming the product. So, another way of seeing this, well, we said before that their utility was V of Q plus M, okay, and M was Y minus PQ. Okay. So the utility was V of Q plus Y minus PQ. What we have here, what consumer surplus is giving is V of Q minus PQ. So if we take away Y from utility, U minus Y is V of Q minus PQ. Okay, and we evaluated this at the price they actually pay. Okay. This is consumer surplus. Okay. So consumer surplus is their utility minus the income they started out with. So again, consumer surplus is this direct measure of utility when you have quasi-linear preferences. And with quasi-linear preferences, the unit of utility is money. Okay, that's another reason why they're convenient. So, as I said before, you can think of this V function as being their value gain from consuming a certain number of units. And you can think of Y as their income as the utility they get even if they consume nothing at all. Okay, so taking utility minus what they get anyway, it's kind of their gain in utility from consuming the product. Okay, so that's why we look at consumer surplus. So when we do, so we've kind of finished on the individual side for now. We finished on the demand side. When you solve a simple monopoly problem, you have some demand curve for the consumers, and then the producers have some cost function. Okay, so we're now going to move on to the production side and look at these cost functions. So a cost function, C is a function of Q. It's going to give the total cost of producing Q units. Okay, so C as a function of Q is the total cost, not marginal cost. So if we want marginal cost, well, we just differentiate the cost function. Okay, so marginal cost throughout is going to be C dash. And a firm's average cost is going to be the total cost divided by the amount they're producing. So C of Q divided by Q. And I ask here, when average cost equal to marginal cost, for what class of cost functions would average cost equal marginal cost? Go on. You're looking like that. Are you shy because of a video camera?
Is it as part of the AC curve, the average cost curve? That's what they MC.
Well, yeah, AC and MC will always cross somewhere. that's true, but for one class of cost functions, they'll always overlap.
Is when there's no fixed cost.
When there's no fixed cost, and marginal cost is what? Is what? So, okay, so when there's no fixed cost and marginal cost is constant, that was where we were going. Okay, so if each unit of the good costs a constant amount to produce, okay, so then your cost function is just C of Q is, I don't know, some value, some constant, A times Q. So if you produce 2 units, it costs you 2K. If you produce 10 units, it costs you 10K, etc., etc. So with linear costs like this, the marginal cost C dashed of Q is the derivative of this, which is just K, and average cost CQ over Q is KQ over Q, which is also okay, so if you've got linear cost of production and no fixed cost, then marginal costs are always going to equal average costs. In reality, there are always some fixed costs, and generally, the more you produce, the higher your costs are going to be, beyond some certain amount. Your factory's only so big, you've only got so many workers. Okay, if you want to produce 2 times as much, you've got to persuade people to work twice as long, which means they're not going to be sleeping very much. You're going to have to pay them a big overtime bonus in order to get them to work that extra amount. Okay, so the more you produce, generally, the higher your marginal costs are. And there's a little problem here. So suppose output is produced using some production function. I say, okay, so the input to the production function is just labour, and it generates output. So output is F of labour, and labour is paid a wage W. What's the cost function going to be here? So what you have to think is, if I want to produce Q units, how much labour do I have to demand? So we're going to use a trick that we've already used today. Okay, so look, if Q is F of L, then if I apply the inverse of F to both sides, then F inverse of Q is F inverse of F of L. Okay, what's F inverse of F?
1.
Yeah, so these kind of disappear. That's just L. Okay, so the labour demanded in order to produce Q units is given by the inverse of the production function, F inverse. I'll write it on this. Okay, so Q is F of L. F inverse Q. So this is telling you how much labour you need. Well, we want the cost function, so your cost. Each unit of labour costs you W. Okay, so the cost function, C of Q, is just going to be L times W, which is W times F inverse of Q. So C of Q is L W. Okay, so even if I don't tell you exactly what the cost function, what the production function is, we can still work out what the cost function is just by inverting the production function. Okay, so production functions and cost functions are kind of different. And there's an example here of a cost function. And the exercise was just, if this is the cost function, sorry, if this is the production function, what's the cost function? I'll leave you to do that in your own time, and we can look at it in the class. Oh, I should have mentioned, a lot of my slides have a particular section of Oz Shai's book in the title to direct you to the relevant bit of reading. So we've done the consumer side, we've done firm costs. Next thing we're going to look at is profits. Okay, if we're going to get to a standard monopoly problem. So you can think of firms as either choosing prices or quantities. If there are several firms, then whether they're choosing prices or quantities is going to make a difference, as I guess you remember from Bertrand and Corno. And whether firms are choosing prices or quantities will give you a different profit function as well. Okay, so you can write profits as a function of price or profits as a function of quantity. If you want to write profits as a function of price, well, then it's price times the quantity demanded at that price. Okay, this is their revenue, minus the cost of producing that quantity. And what's the quantity? Well, it's the demand curve at the given price. Okay, so this is the cost of producing the quantity that's demanded at that price. Alternatively, you can write profits as a function of quantity, in which case revenue is going to be the price that people are prepared to pay at that quantity, times the quantity, minus the cost of producing that quantity. Okay, so just as for two types of demand curves, normal demand curves and inverse demand curves, we're going to have two types of profit function. Sometimes it'll be easier to work with one, sometimes it'll be easier to work with the other. Now, if this, if the inverse demand curve is really just the inverse of the demand curve, okay, then using either of these two is going to give you the same answer. Okay, so as long as your inverse demand curve is actually the inverse of the demand curve, it doesn't matter which of these two you use. It'll just be easier to use one or the other different times. And as I said, in either case, this term or this term is total revenue. Price times quantity is total revenue. So what's marginal revenue going to be? Sorry, say that again. Is it just for price? So that's certainly, so marginal revenue is the change in revenue as you produce another unit of quantity. Okay, so what we want is the derivative of PQ times Q with respect to Q. Okay, so this is of the form derivative of, so this is a product, right? Have you seen this? The derivative of UV dx is derivative of u with respect to x times b plus derivative of b with respect to x. This is how you take derivatives of products. You remember that? Yeah. Okay, so this is a product rule for differentiation. That's what we're going to use here. So derivative of this is derivative of the first bit, so p dash to q, times the second bit, q, plus the first bit, p of q, times the derivative of the second bit, which is just 1, right? Derivative of q with respect to q is just 1. So this is what marginal revenue looks like. So here's price, the term you mentioned before. Then there's this other term. Okay, what's that other term capturing? So if you produce another unit, you get some income because you're selling another unit, and the amount of income you generate is the price. Okay, so that's that term. And this second term is capturing another effect. What's that capturing? So what's happening is, if you produce another unit, the people are prepared to pay less for all of the units you're currently producing. Okay, so you get the price of this new unit you're selling, but you also have to sell all of the other units you're currently selling for a bit less. Okay, so Q here is all the units you are currently selling. P dash Q is telling you how much less you have to sell for that. Okay, so you've produced another unit, and as a result, you have to sell everything at a slightly lower price. Okay, so we're going to be two components to marginal revenue. Right. So here's the extra unit you're selling, so price is the amount of money you're getting from selling that. P dash is telling you how much you have to reduce the price on all the units you were previously selling. Q is how many units you were previously selling. Because as you produce more, people are going to be prepared to pay less in order to sell all of them, right? Because demand curves are downward sloping. What have I got? Okay, so here's the demand curve. Here's the marginal cost curve. And what's this grey area I've shaded? So, pardon? Yeah, produce the surplus or profit. Please in the title. So this is produce the surplus now. Okay, it's the area they're selling, their revenue, right, is the area of this box. Okay, they're selling Q star units at a price P star, so they get this box in revenue, Q star times Q star. But they have to pay some costs, okay, and the total cost they have to pay is the integral under the marginal cost curve. Okay, so it's the integral under marginal cost up to the quantity they're producing. Okay, so it's this area minus this area gives you profit. So revenue minus total cost. So let's just see that makes sense. Okay, you remember this diagram from last year or the year before. What is that area in mathematical language? Well, it's the integral from naught up to Q star of the constant function P star minus this red curve, which we said is marginal cost. Okay, so it's the integral from naught up to Q star of P star minus marginal cost. So, marginal cost, well, that's just C dash for Q. Okay, it's the derivative of the cost, the total cost function with respect to quantity. So here we've got the integral of P star, which is just a constant between naught and Q star. Okay, that's just this box again. P star, so that integral is going to be P star Q star. And then we've got the integral of the derivative. Okay. So just as before, we're going to use the fundamental theorem of calculus. The integral of the derivative just gets you back to the original function. Okay, so here we're going to have minus C of Q. We also have to subtract the cost at 0. And this is because you remember when you integrate, maybe you want to integrate y is x between 1 and 2. Okay, you remember that the indefinite integral of x dx is half x squared. You remember that from your A-level maths, hopefully. And if you want to work out the integral between 2 points, okay, you evaluate this at the right-hand side minus the value of the left-hand side. Okay, so this is half times 2 squared minus 1. Okay, that's all we're doing here, okay? we've taken the indefinite integral at the right-hand side, which is just C of Q, and we've subtracted the indefinite integral at the left-hand side, which is just C of 0. Okay, so producer surplus is just this expression, okay, and we can rewrite that as, so it's price times quantity minus total cost, which is just profits, minus makes a plus, okay, C of 0. So producer surplus is just the profits they're making plus the cost they have to pay even if they don't produce anything at all. Okay, so producer surplus is just the gain in value in profits they've got by producing a certain quantity. Okay, we don't count the cost of producing nothing as part of producer surplus. So, you know, just as consumer surplus was the value gained by consumers, here producer surplus is the value gained by producers. And if there are no fixed costs, okay, then C of 0 is just 0, okay, so producer surplus is just equal to profits. So in the special case with no fixed cost, producer surplus and profits are the same thing. Okay, so we've seen consumer surplus, we've seen producer surplus. You've probably heard of welfare as well, which is the sum of consumer surplus and producer surplus. Yeah? So let's define this thing, welfare, as the sum of consumer surplus at a given quantity plus producer surplus at a given quantity. Well, let's plug in the definitions of these two things. We showed before that consumer surplus was equal to this V function, value minus the amount they're paying, PQ. Producer surplus is revenue minus their costs, with this little correction for fixed costs. Okay, so we've got a minus PQ, we've got a plus PQ, they cancel out. Okay, so then welfare is just the value gained by consumers from that quantity, or sorry, I should say the amount the consumers value consuming that quantity at, minus the cost of producing that quantity, plus the cost of producing nothing at all. And if you're a social planner, you'd want to choose the amount produced in order to maximize welfare, right? You want to, you know, welfare is the total value gain in the economy. So if you want everyone to be as well off as possible, you want to maximize welfare. If we're going to maximize welfare, we just have to differentiate it and set the derivative equal to 0. Okay, so if we differentiate this expression with respect to q, you're going to get v dash q minus c dash q is equal to 0. Or equivalently, v dash q is equal to c dash q. But remember, we said that this marginal value thing, from the first order condition of the consumer, that was just for price. Okay, so v dash q is just for price, or the inverse demand curve. So the welfare maximizing quantity is the one that says for price equal to marginal cost. Okay, so all we've shown is that when price is marginal cost, welfare is maximized. When do you get price equal to marginal cost? What competition? Pardon? Yeah, exactly. So if you've got perfect competition, you get price as marginal cost. Okay, and what we've shown is that that's actually in the best interest of everyone. Okay, so perfect competition is good for society. When you saw these things before, you probably looked at the monopolist problem. Okay, we can now do that pretty quickly. So monopolist has some cost function C of Q that face a demand curve P of Q. So their profits as a function of quantity are But price, but people are prepared to pay at that quantity times the quantity. That's revenue minus total cost. So the first order condition is what you get when you differentiate this and set it equal to 0. Okay, this was total revenue, so the first term is going to be marginal revenue. So just as before, you know, we use the product rule on this expression. Okay, so you're going to get P dash Q times Q plus P of Q minus C dash of Q. And this bit's marginal revenue, this bit's marginal cost. Okay, so the first order condition of a monopolist is just that marginal revenue equals marginal cost, which you probably saw in the first year, right? And here it is graphically. The marginal revenue curve is normally like the demand curve, but just rotated around a little bit. Okay, so here's the marginal cost, here's marginal revenue. So marginal revenue equals marginal cost here. So that's giving you the quantity they're going to produce. Okay, but at that quantity, they're going to set a price up here on the demand curve, and they're going to make this amount in surplus. Consumers are going to make some surplus as well, but we also have this area here, which you've seen before. We call it deadweight loss, because it's the inefficiency, it's the amount of value that's lost due to having monopoly rather than perfect competition. Okay, under perfect competition, price is equal to marginal cost, so we're at this point here. Okay, so you just imagine the graph under perfect competition with a straight line along here. This area under the marginal cost curve would be producer surplus, this area above would be consumer surplus. So by having a price below marginal cost, and by having this monopoly, there's this area of value that could have been surplus, which isn't surplus. Okay, so the area of this triangle is just lost. You know, it's surplus, but either consumers or producers could have gained, but because they're monopolists, they're setting prices too low, this value is just lost. It's an inefficiency one. Am I doing time? Okay, so here are some problems. I'll go through these in the class if anyone bothers to turn up. So the first one is you've got a linear demand curve and linear costs. Show something about the quantity produced under monopoly and the quantity produced under perfect competition. Okay, so I tell you what the answer is. I just want you to make sure you know how to get to this answer. And the nice thing about linear demand and linear cost is that under monopoly, the quantity produced is half the quantity under perfect competition. Okay. And then I go on to ask what consumer surplus, producer surplus, and deadweight loss are. That's a bit difficult, so don't worry if you struggle a little bit with that. And then I ask the same question with isoelastic demand. Okay. And what you get under isoelastic demand, which the price a monopolist will choose, is here's marginal cost, okay, C dash Q, and you just got a constant times marginal cost. You've got this constant times marginal cost. So with isoelastic demand, what a monopolist is doing is they're setting price as a constant markup over marginal cost. You know, so maybe they're always pricing at 30% above marginal cost. Okay, so this is another convenient feature about these isoelastic demand curves. And then there are some further problems here, including some exercises from our shy. Okay, so now have a go. Okay, so before you work it off, what did we learn today? Well, consumer surplus we showed to be the value gained by consumers, only with this quasi-linear utility. Okay, so it is, consumer surplus is already quite restrictive. You have to have quasi-linear utility to make sense looking at consumer surplus. And producer surplus was the value gained by producers by selling a certain quantity. Monopoly was inefficient because it resulted in this deadweight loss, this surplus that could have been gained by someone, but wasn't because they priced too low. Okay, so what you should be able to do, you should be able to work with these types of demand curves, calculating lessons. Okay, I know this was quite boring. I know Monopoly, you've seen it all before. As we go forward, it will be less and less stuff that you've seen before, but I needed a bit of revision just to make sure that everyone can handle these mathematical tools that we start. Yeah. So, give me another week if you thought it was boring.